Hey, welcome to your practice test. I hope you've been studying a bit on vectors to get ready for this one. So let's have a look. What I want you to do now is to put your name on the paper, and then what we're going to do is go through one by one each of these questions. You pause the presentation, have a go, and then after question 10, I'll come back and you can watch me do each of the questions. Have a look up here. Time allowed 55 minutes, so your time is going to start now. Here's the first question. I want you to have a go, pause it, and have a go. Let's come down now to part B of that question. Pause it, have a go. And part C there, all related to the information given at the beginning of part 1 there, or in question 1. All right, how are you going? Feeling you're getting some marks? Let's go to question 2. Parts A and B there. Pause it, have a go. Question 3. Let's bring that up on screen there. 2 marks. Question 4. 2 parts, check it out. Question 5. Question 6. Question 7. Question 8. Question 9. Question 10. That's part A. And we've got part B coming up. And it's a fairly long one. 5 marks for that one, I think. Okay, so there's the paper. Now, I hope you had a go, and I'll give you the answers now. So let's go right back to the beginning, and let's see how to do it. Show on a Cartesian plane with clearly labelled axes the points A, B and C. Okay, so let's come up here and have a go at drawing some axes. So if we draw a set of axes here, a bit wonky that one, I'm doing it on screen here. So there we have it. Label the axes carefully, and they are position vectors. Did you see that? So from the origin, 3, 3. So that first vector there is 3, 3, and that's point A. And then B is -2, 7. So let's count up here. 1, 2, 3, 4, 5, 6, 7, and it's -2. So we're going like that, position vector, -2, 7, that's point B. And -6, 1, 1, 2, 3, 4, 5, 6, -6, 1 is there, is C. So they are our vectors, A, B and C. How did you go with that? Clearly labelled axes, etc. I think we've done that okay, showing the vectors as well. Okay, well come on down. What's our marking scheme there? Well, our marks are 1 for the set of axes. We need some sort of scale on there. 3, better put this as -6, and this is 7 to explain the scale. And then those 3 points, 1 for each one there. Okay, how did you go? All right, come on down and let's have a look at part B. A, B and C are 3 vertices of a parallelogram. A, B, C, D, find using vector methods the position vector of the point D. Well, let's go back and have a look. D, let's let D be the point X, Y. And from above here, D is going to be what? Down here somewhere. We've got to use vector methods, so let's bring that back. And what would we say? Well, AD going from there to there would have to be equal to BC. So let's do that. AD, so what was A? A was the point 3, 3, because it was position vector. And then B was the point neg 2, 7, and C was the point neg 6, 1. So let's do it now and see if we can do AD. A to D would have been the vector x take 3, y take 3, and B to C would have been parallel, would be neg 6 take neg 2, would be neg 6 plus 2, and 1 take 7. So this is neg 4 and neg 6 there. B to C. Remember, it's the second coordinate, the second point's coordinates minus the first. All right, so what we're going to say is, if they are parallel, AD is parallel to BC, then the vectors would be equal. It implies x take 3, y take 3 equals neg 4, neg 6. So just coming down a little bit here, we would say that implies x take 3 is neg 4 and y take 3 is neg 6. So that means x is neg 4 plus 3, which is neg 1, and y is neg 6 plus 3 is neg 3. So D is the point neg 1, neg 3. Just notice the curved brackets for a point. Now let's have a look at whether that rings true. I've almost got it right here, haven't I? Neg 1, what did we say it was? Hang on, let's come down again. Neg 1, neg 3. So neg 1, neg 3, a little bit out here. It should be there. Okay, that would be our point D. Okay, as we've actually found it. We weren't asked to put it accurately on the graph in the first place. So let's have a look at the 4 marks here. There will be 1 mark here for getting AD, 1 mark for BC, 1 mark for putting them equal, and 1 mark for the answer. I'll get rid of these ticks because they're not marks. Okay, how are you going? Getting a few? Let's go down, find BD in terms of I and J. Well, let's work out the BD vector. It's the x-coordinate of D minus the x-coordinate of B. So it's neg 1, take neg 2 is neg 1 plus 2, and 3 minus 7. Okay, so this is the point 1, neg 4, but it says in terms of I and J, so BD vector is 1I, take 4J. Okay, only 2 marks. So here, 1 mark for that and 1 mark for that. Okay, did you get your 2 marks? Come on down now. Let's have a look at question 2. Find x when A and B are parallel. A and B are parallel implies A is K times B. So that means x for that vector is equal to K times 2 neg 8. So from the x components you can say K is neg 2, neg a half, because neg a half times neg 8 would give the 4. Okay, so maybe you want more explanation of that. 4 equals neg 8k, 4 over neg 8 equals k, comparing the y coordinates. Therefore, x is neg a half times 2, x is neg 1. Okay, so the first thing is to show that you know it's a scalar multiple. And the next thing, I guess, is to write this, find k, and then do it to the x value. Okay, so neg a half times 2 neg 8 will give neg 1, 4. Okay, very good. How are you going? Mark it carefully. Let's keep going now. Write a vector equation for following diagram, making W the subject of your equation. So let's start with W as the displacement of that point. So W is the displacement of that point. What's an equivalent displacement? Well, we could go V and then take U going around here, and then take P down here, take z along there, plus y because we're going in the direction of y, and then plus x. That'll be the same displacement of that point right around the outside. Okay, so I don't know, here for 2 marks, you need to have all the signs right. So if you've got one sign wrong, then you lose 1 mark. More than one sign wrong, then you lose all 2. Okay, so just get that idea of displacement. You could actually write that in various ways. You could do the sum all around the figure, sum of all vectors, and then put w by itself on the other side. Could do it that way. Okay, let's go down and have a look at question 4. Vectors I and j are univector along the x-axis and y-axis. We know that. Vectors u equals neg I plus 2j and v equals that are given. Find u plus 2v. Okay, so u plus 2v is equal to neg I plus 2j, and plus 2 lots of v would be 6i plus 10j. Multiplying by a scalar, multiply both the components. Let's collect up the neg I and the 6i. That's 5i. 2i plus 10j is 12j. Okay, so that's your answer there. So the first thing is 1 for that line, for multiplying v by 2 and adding it up, and 1 mark for that line. A vector has the same direction as u plus 2v, has magnitude of 26. Find w. Okay, so w has to be some multiple, because it's parallel or same direction, as your answer in part A. Okay, but now we better look at the length of this vector, okay, because we want to make a vector of magnitude 26. That'll tell us our cave size. So the size of 5i plus 12j is square root of 5 squared plus 12 squared. Remember that. Length of a vector, square root of 169 is 3. That's a Pythagorean triple. So therefore, if w is going to have length 26, w equals 2 lots of 13, doesn't it, to make 26? Okay, so it looks like that, which is 10i plus 24j. Fair bit of work there. Somewhere we need to have the idea that you're multiplying it up by a multiple, and then by a scale factor of k, a scalar, and then 1 for the answer. Had to work fairly hard for those 2 marks. How are you going? Having fun? Let's see if we can get some more. Okay, here's question 5. Vectors u and v are given by those 2. Find scalars a and b, so it's au plus v, bv equals 5i plus 12j. So let's work out a is a scalar. A times u would be 3ai plus 5aj. Oops, a is not a vector there. A is a scalar. Okay, 5aj. All right, and what's bv? B is a scalar here, and so it's 5bi plus 12bj. Okay, so let's add them up now. AU plus BV will be equal to 3A plus 5BI, adding the I components, and 5A plus 12BJ. And this has to equal 5I plus 12J. So what does that mean? Got 2 equations, 3A plus 5B equals 5, equation 1, and 5A plus 12B equals 12, equation 2. Now, in this particular course here, we could just use the calculator to do that and solve it with equa mode on the calculator. So go equa, simultaneous, 2 unknowns, and enter that and come up with a solution. Let's do it though by multiplying equations up. We could multiply this one by 5 and this one by 3. We'll get 15a plus 25b equals 25, and 15a plus 36b equals 36. Okay, so if we subtract equations, these go out. 25 take 36 is neg 11b equals neg 11, so b is 1, and substituting it back, sub into equation 1, we would have 3a plus 5, so a would be 0, and check it in equation b. Yes, it works. So a is 0, b is 1. Do it the long way. I think, though, you go for the calculator if you're allowed to, and in this course you are. So let's look at the 4 marks now. There's 1 for getting both of these, 1 for the addition, 1 for getting the equations, and 1 for the answer. A is 0, b is 1. You've got to have both of those, though. So you've worked pretty hard to get that, but of course you were meant to use Equimode on the calculator. Right, let's keep going now. Question 6. ABC is a rectangle and O is the midpoint of AB in the diagram below. So first thing you do, because that's given information, mark it on your diagram. Express each of the following vectors in terms of OC and OD. CD. Now CD is going from C to D, like that. So that displacement, CD, would be the same as coming down here, CO plus OD. Now, it says in terms of OC and OD, so we've got to change this to OD minus OC, or neg OC plus OD. Okay, you could do that as well. Okay, OA. Let's have a look at OA. We're going from here to here. So OA would be equal to, come up this way, OD, and then plus DA. DA coming down here. Now we want it in terms of OD. Okay, so what could we do? We can say, well, let's try and get DA in terms of, DA in terms of OC and OD. Can we do that? DA down here. Okay, well, it's an interesting one, this one, because it would have been easier to do AD first and come back, because OD plus DA needs the DA. So I don't know, do you want to do that first? I think that might be easier. AD, if you do AD first, going up to AD, that's the same as minus OA plus OD. Okay, so really what we're about here is trying to get rid of one of those. So we want OC and OD, and we can choose to do DA or OA. So if you do DA, let's have a look at what you get. So I think actually probably we'll do this. COA, OA is here, neg OA. OA is equal to a half of CD, isn't it? We haven't used that yet, back up there, because we're told it's a half and this is a rectangle. So vector CD is the same as OA. So this is neg a half, and we can use what we had in the first one. OD take OC. I think that's the best way of doing it. Okay, working back and using part A. Okay, so this is OD take a half OD is a half OD plus a half OC. Do you get that? Neg OA there is a half of CD. Neg a half of CD. Okay, and now of course we can come across to this one, OD, and then plus DA is the negative of this. Okay, DA is negative AD, so it's minus a half OD minus a half OC, taking away AD because we want DA. So what have we got now? We've got a half of OD, take a half of OC. Okay, how'd you go with that? Fair bit of work there. Let's have a look at a mark scheme for it now. It's 5 marks, so this would be 1. I think we'd need 2 there for getting that answer. Fairly hard work here, so there'd be those 5. Fairly tricky, that one. Okay, let's go on. Let's keep moving. P, Q and R are vectors given in component form. Find x if 3q, take x equals r plus 2p. So 3q is 3 times this. Take vector x, so we don't know what that is, equals r, which is 4, 5, plus 2 times p, neg 2, 3. Let's multiply it out here. 9 neg 12, take x, is equal to 4, 5, plus neg 4, 6. So let's do this right-hand side. That comes to vector 0, 11. So vector 9 neg 12, take x equals that. So let's say that x is, putting it on the other side there, x is that vector, take away 0, 11. So therefore 9 take 0 is 9, neg 12 take 11 is neg 23, equals our missing vector x. And you can check it back in the original. We really should have implied signs here. That's a neater way of leading on right the way through there. So did you get that one? How did you go? Let's look at the 3 marks. So there's 1 for multiplying the vectors up, 1 for adding, and then 1 for the subtraction. Fair bit of work there for 3 marks. How are you doing? Let's treat this as a good learning experience. There's some reasonably hard ones here. Projection vector, x of A equals 2 neg 4 onto B. Okay, so let's just check what projections mean now. So the projection, if you remember it, is how much that's projected onto there, and that's theta. So projection is the length of A by the cos of theta, which is A dot B, okay, divided by B, just remembering that A dot B is length of A, length of B, cos theta, okay. So that would be the length of the vector, and I'm going to do that first. So here it's A dot B, which is 2 times 3 is 6, plus 5 over the length of B square root of 10, square root of 3 squared, and neg 1 squared, so root 10. So that's 11 on root 10 is the length of that projection vector. Okay, but it's got to be in the direction of B. So B's direction, B is 3 neg 1. So let's bring it back to a unit vector. So it's 1 on root 10, 3 neg 1. So the projection vector, so this is actually part A now, is 11 on root 10, or 11 on 10 times 3 neg 1. So the idea there, of course, is that you're getting a unit vector in the direction of B, and then the projection is the A dot B over length of B, and you're going to give that direction to the vector, give that length to the vector. So that's actually part A, and part B we did up here, did the length of the vector first. Draw a clear sketch of this projection vector. All right, let's have a look. 2 neg 4, let's do it over here, running out of room here a bit. Let's get a bit straighter than that. So here, we could just come down here a little bit. 3 neg 1. Okay, so here it's the vector 3 neg 1, so I think we better do it all. Coming from here, 2 neg 4 down here, make that a position vector, that's A, and then 3 neg 1 is here, so that's B, and the projection of A onto B is longer than B, and it's that whole projection vector there. So 6 marks, a lot of work for that. So we'll give 2 for the length, 2 for the projection vector, and 2 for a good position here on the plane, and you should have them labelled. Okay, how are you going? A lot of work. Let's go down and look at question 9. Find the angle ABC. Angle ABC is always said like that. Oops, let's draw that a little bit better there. ABC. ABC. Okay. Now, if you want that acute angle ABC, you must work out from the point in the middle of the angle. So here, the cos of that angle theta is BA dot BC over the length of BA by the length of BC. Okay, so we need these vectors. Let's work them out. This is A, B and C. So BA, B to A. X value of A minus X value of B. So that's going to be 5. 3 take neg 2. Neg 1 take 3, neg 4. BC, that vector coming out. BC, 7 take neg 2 is plus 9. 4 take 3 is 1. So let's work out the cos of theta now is BA, okay, dot BC, 5 times 9 is 45, plus neg 4 by 1 is neg 4 over the lengths, root of 25 and 16 is root 41, here root 82, okay, so this is 41 over root 41 root 82. Okay, so theta is the cos of that, inverse cos of that, sorry. Okay, so check the numbers there. Do you agree with that? And what we must do now is use a calculator. So on the calculator we get 45 degrees. Okay, let's have a look at the mark scheme for that. There's one for showing you know how to get the cos, one only for each of those vectors, and then one for the correct substitution and one for the angle. So a fair bit of work again for that one. Okay, come on down, last question now, and see how you went with this. In the rhombus OABC drawn below, let OA equals A, we've got that marked. OC equals C. You may assume that the rhombus is a parallelogram. We're supposed to know that. Find AC and OB in terms of A and C. Okay, so A to C across here is displacing this point down here and around here. So AC is equivalent to neg A coming opposite to A here plus C. OB displacing O to B. O to B is the same as coming around here. C there plus CB. And what do you notice about CB? Because it's a parallelogram, this displacement C to B is the same as A, equivalent to A. So it's C plus A. Okay, so let's mark that. one for that one, and actually one for that and one for that. So that's 3 there. So getting those in terms of A and C. Now we have to come down and let's look at the second part of the question using AC.OB. Let's have a look. AC, we better look carefully. This is neg A plus C, and OB, taking it from up there, is C plus A. So let's now use the dot product. Now, to prove the diagonals rhombus are perpendicular, so we expect the dot product to come out to 0, don't we? So let's do it. AC dot OB will be neg A plus C dotted with C plus A. Do you know the rules for the dot product? So it's neg A dotted with C plus neg A dotted with A plus C dotted with C. We're doing all these, and then plus C dotted with A. Okay, now neg A dot C is the same as A dot C is the same as C dot A, so they'll go out, and we should put this down here now. I'll put it down here. Since A dot C is equal to C dot A, and one's negative, so it'll take the other one away. Now what have we got? Neg A dot A plus C dot C. Let's go just back up page again here and just check this out. Now this is a rhombus. So here, what can we say? The length of A and the length of C are the same. So let's have a look here. A dot A and C dot C. Let's do it a little bit differently. I don't want that in there really. A dot A, or the minus of A dot A, is here going to be equal to the length of A squared, because A dot A, length of the two vectors, cos of the angle between them, cos of theta is 0, so A dot A is A squared. We've got a negative there. But C dot C is, for the same reason, going to be C squared, but this is going to be negative, and this is going to be the same length, isn't it? Because in brackets here, since the length of A equals length of C in a rhombus. So that equals 0, which implies AC dot B OB, we can just put AC and OB are perpendicular. Therefore, diagonals are perpendicular. We didn't have to say they bisect each other, they're perpendicular. All right, so let's look at some marks. I think there are 5 there. Down the bottom, 5 marks. We'll just come up here. 5 marks. So there's nothing for this line because that's from before. 1 for this dotting together, 1 for removing the C dot A minus A dot C, 1 for the square, and then 1 for recognising the two lengths will be the same, and then 1 for the conclusion. Dot product is 0, and therefore they're perpendicular. So there's the 5 marks. How did you go? Well, total them up and put it at the top of your test now. Let's go back to the top. And what did you get? Here, how close to 50 did you get? It was a fairly long test actually, so I hope you did well. Go back over the ones that you didn't get right, check some from a textbook, get ready for the proper test, and I wish you luck. Cheers for now.